pair of lines through origin. We have the x coordinate and y coordinate. We know what is the equation of a line lying on the x-axis is, right? So y is equal to 0 is the x-axis and x equal to 0 is the y-axis. Now in our high school algebra we have seen that x equal to 0 or y equal to 0 can be combined together into x times y equal to 0. So this x times y equal to 0 is the equation of both x and y axis or axis, that is two lines. So we have one equation for two lines. Let's look at equation of a line. Let's say x a1x b1y equal to 0. Now here there is no constant term, that is the y-intercept is 0. That means this line is going to pass through the origin. Similarly, a2x plus b2y equal to 0. That means we can combine them now, again using the same logic. a1x plus b1y, a2x plus b2y equal to 0. Now let's expand it. a1 a2x square plus a1 b2 xy plus a2 b1 xy plus b1 b2 y square equal to 0, and a1 a2 x square plus a1 b2 plus a2 b1 xy plus b1 b2 y square equal to 0. Now let's combine this. Let's combine this into a single letter. Let's substitute this with a single letter and this with a single letter. So let's say ax square plus fxy plus by square equal to 0. So you have an x square, you have a y square, and you have xy. Now this equation represents two lines passing through the origin. Now, this is called a homogeneous equation of degree 2 in x and y. Now remember, this equation is for two lines passing through the origin. Now let's take it a bit further. So let L1 be a1x plus b1y plus c1 equal to 0. That means now it has a y-intercept. That means it need not necessarily pass through the origin. L2 a2x plus b2y plus c2 equal to 0. Following the same logic, let's say L1 times L2 equal to 0. That means a1x plus b1y plus c1 times a2x plus b2y plus c2 is equal to 0. Now let's expand this. a1 a2 x square plus a1 b2 xy plus a1 c2x plus a2 b1 xy plus b1 b2 y square plus b1 c2 y. No, b1 c2 y plus a2 c1x plus b2 c1y plus c1 c2 equal to 0. Let's put it in order. a1 a2 x square. Now let's take xy now. So xy is this. Okay, so a1 b2 plus a2 b1 xy. Now let's take x now. This is x, this is x. So a1 c2 x, let's take it as common out. a1 c2 plus a2 c1 x. Now y is this, b1 c2 plus b2 c1 y plus c1 c2 and plus b1 b2 y square is equal to 0. Now here this is again a quadratic equation in x and y. It can represent a pair of lines under certain condition. Now we will look at that condition at a later point. So just remember that every quadratic equation in x and y doesn't necessarily represent a pair of lines. Only when certain conditions are satisfied, then only they represent a pair of lines. Whereas a homogeneous equation in x and y of degree 2 is always a pair of lines. Okay, so basically let's focus on a pair of lines passing through the origin. So let's say this and let's say this. So let's say this is y is equal to m1x, y is equal to, now let's say the equation is ax square plus 2hxy plus by square equal to 0. by square, let's solve it for y. by square plus 2hx y plus x square. This is a quadratic equation. Okay, let's apply the quadratic formula. So y would be equal to minus b, that is minus 2hx plus or minus square root of b square. So that is 2hx square minus 4ac. 4 times a is b here and ax square divided by 2a. Here a is b. Okay, so let's see whether we can or how we can simplify it. Let's say this is 4h square x square minus 4bax square by 2b. Now minus 2hx plus or minus 4 is common, so let's take 4 out. So if we take it out, it becomes 2 square root of that, and this will become, x square is common, so x can be taken out, so we are left with h square minus ab divided by 2b. Now we can take out 2 and x out, so 2 and x out, so minus h plus or minus square root of h square minus ab divided by 2b. Now 2 and 2 gets cancelled. Now if we minus h plus or minus square root of h square minus ab, and x we take it out, by b plus 0, y is equal to, right? So this is nothing but a line. Actually, two lines. Why? Because there is plus or minus. Here, this is the slope and this is the y-intercept. Since it is 0, it means it is passing through the origin. So m1 would be minus h plus square root of h square minus ab by b, and m2 is equal to minus x minus h minus h square minus ab by b. The sum and product of these slopes can be very useful. So let's look at the sum. So m1 plus m2 would be minus h plus square root of h square minus ab by b plus minus h square minus ab by b. Let's take the LCM. So plus square root of h square minus ab minus h minus square root of h square minus ab by b. Now here this and this gets cancelled. So minus 2h by b is the sum. What about the product? Minus h plus square root of h square minus ab by b times minus h minus square root of h square minus ab by b. Now this is a plus b times a minus b, right? Similar to that. So we know what the solution would be. So minus h square minus square root of x square minus ab the whole square by b square. Okay, so this becomes h square minus, and the square root and the square gets cancelled, and if we remove the bracket, this becomes minus h square plus ab by b square. This and this gets cancelled, square and this gets cancelled, and we are left with a by b. So the sum of the slopes is minus 2h by b and the product is a by b. So we have seen what are how a pair of lines can be represented, a pair of lines passing through the origin, and what their slopes are. What are the sum of the slopes and product of the slopes. That's it for today. Bye.